Every element that we know of has the same number of protons. All boron atoms, which goes by the letter B, have 5 protons. But not all boron atoms are the same. There are some boron atoms which have 6 neutrons, so it's 11 there, and there's some boron atoms which have 10 neutrons. Those are the two common types of boron atoms, and they're called isotopes. And every element has a natural percent of each of the isotopes. In the case of boron, 20% are the 10 boron version, so 10 boron, and 80% are the 11 boron version. And that means that their average mass is a weighted average. So the way you do a weighted average is you take the fraction. 0.20 have a weight of 10 AMU, and 0.80 have a mass of 11 AMU. Notice the fractions add up to 1, and that equals 10.8 AMU. And so if you look at boron, you'll discover that it is 10.8 AMU, or 10.8 grams per mole. And this is called the atomic mass. So the atomic mass is based on the natural abundance of the various isotopes that an element has. Let's do a problem for magnesium. So magnesium has, and we'll do the problem like this, it has 3 common isotopes: 24 magnesium, 25 magnesium, and 26 magnesium. And this time we're going to do the problems very carefully, not just give you approximately the masses. I'll give you exactly, to many significant figures, the masses. The fraction of magnesium naturally, that's 24 magnesium, is 0.7899. And we're going to just work this out. The amount of magnesium 25 and 26 is 0.2101. And the masses of these 3 forms are 23.9850 AMU. So we know these things to lots of sig figs. 24.9850 AMU. And 25.9826 AMU. And sig figs, by the way, is the number of digits. And so just roughly, the 23.9850 is to 6 sig figs. 0.7899 is to 4 sig figs. Okay, and the problem I'm going to ask you is, we know the actual atomic mass. You can just look this up on the periodic table. The atomic mass of magnesium is 24.305 grams per mole or equivalently AMU. And then the question is, let's figure out just mathematically then, what are the fractions of 25 magnesium and 26 magnesium? So let's just call this, we'll solve this problem. This is a little algebra problem. I'll call this X. That's the thing we want to determine. And the fractions have to add up to 1. So this will be 0.2101 minus x. So if you add up these three fractions, it adds up to 1. And we can figure out x because the weighted average of the fractions by the masses is the atomic mass. So 0.7899 times, I shouldn't use an x, that'll be confusing, times 23.9850 plus x times 24.9850 plus the third fraction is 0.2101 minus x times 25.9826. And that whole thing has to be this is the weighted average, must be the atomic mass of magnesium, which you can get from the periodic table. And that's 24.305. This is an algebraic equation with one unknown x. We can solve for it, and if you do that, you'll discover that x is equal to 0.0999. And you'll be getting much harder versions, actually, eventually, by the time you get to the test, of these weighted average problems. But you'll always have the periodic table, which has the atomic mass of each element.